Hey, this is one class you don't want to cut. Networking 101. You know, if you've been in networking anytime at all, chances are you've heard of MPLS come up in a discussion. Multi-protocol label switching is a pretty big topic, but I'm going to go ahead and break this down for you a little bit and show you some of the very basics of what it really does, and then you can go ahead and grab more details as we go on. So MPLS, multi-protocol label switching, is a really cool technology that allows us to have all the advantages, the routing advantages that Layer 3 provides, but the high-speed transport and the simplicity that Layer 2 provides on the WAN side. Gives us a ton of really cool configuration options, and a lot of the high-speed advantages we see on high-speed WANs now are directly due to what MPLS provides. So let's take a look and see what MPLS actually looks like on the wire. If we got a couple switches here or a couple routers that are forwarding MPLS packets, MPLS is basically a label. It comes from, if you remember the term label switching, it really comes from that type of methodology. And even a lot of the terminology we use here yields back to or holds back to a lot of the label switching stuff. And what it amounts to is that I've got an IP packet here, right? So here's my standard IP packet with all the bumpers, and I've got a small 32-bit tag. So just go ahead and label that 32-bit tag. And in this 32-bit tag, it contains a bunch of different types of information. You know, it could be your IP source and destination, QoS, diffserv, whatever the case may be. You can put that information in this MPLS tag. And as it's being forwarded between your switches, these are actually called label switchers, or LSRs, label switching routers. These label switching routers will forward these tags back and forth between each other, these packets. Now, when I have this packet arrive into this switch, it doesn't, here's where it picks up all the speed. Here's where your advantages of Layer 2 come in. It doesn't have to read inside of this entire packet. It can actually just look at this tag, and then it determines what's called the LSP, the label switching path, and where it needs to forward that traffic. And it's pretty darn cool. Now, if you remember, if you're a frame relay person, you probably have configured up DELCs. DELCs are locally significant to the circuit or to the wire that they're on. Tags are very similar to DELCs in a sense that they're locally significant to that device. So you've got to really plan out your path that we want this label or this traffic to actually flow down. Now, you'll put these in what's called a FEC group. These FEC groups are really kind of designed to determine out what my explicit path is going to be through a system. Now, where MPLS really makes its bones and what it really does give you the creativity to do, not only can you carry your QoS information and really, forward some really sensitive traffic across your WAN, but it allows you to actually start stacking these labels up, right? So now I can take my standard IP frame. Let me go ahead to make this a little bit cleaner. I'll go ahead and take my typical IP packet here. I can put my labels on here, and I can start amending or appending these on this device. And so each of them will have, different little label numbers on them. And the top packet is processed first. It's the last one in. So these arrive like boxcars, right? So this packet comes in, stack, stack, stack. And then the top router, the top label will get processed first, and the next, and the next, and the next. And that will determine how I handle this behavior. The advantage that stacking these labels up gives me is that now basically I can create tunnels inside of a network, right? So now when I'm building out my label switching network, my MPLS network, if you will, I can have a path. These are my LSRs. These are my label switching routers. So as I'm building out my label switching routers here and determining my paths, I can actually have traffic bound for this destination going this way if I want to. And it's going to read and route that traffic. The traffic will always stay on the path we need to. So I've got these little virtual lanes that allow me to tunnel that traffic through and really take advantage of building some incredibly scalable VPN type designs, really high-end networks, so on and so forth. So you'll see MPLS used a lot more in your career as you start to progress down here. I love it. I think it's a great technology. If you're looking for more information on this, there's a lot of really good stuff out there. We've had a guy on our show before. His last name is Osborne. I'm sorry I forgot your last name or your first name, dude. But he wrote a fantastic book on MPLS, and it's fantastic. Thanks, Rob. Rob, my assistant over here, just held up. Said it was Eric Osborne. Thanks, buddy. Appreciate you. Eric Osborne. Go ahead and pick up his book and take a read on that. He's a great guy. If you ever see him at Cisco Live, he's probably one of the coolest guys. He's got a bald head and kind of anthrax-looking beard happening down there. Very cool. But definitely check that out. Really get you started in MPLS. I think right now it's even required for your CCI exam, so it really does help to get aware of it. Don't be afraid of it. You're going to use it. It definitely can be complex, but the basic fundamentals are you're putting a 32-bit label on a packet. We can stack them up, direct this traffic either way through this network, and we predefine our pass out, our label switching pass, before the first packet flows down, so we know how to engineer that traffic across the network. Good stuff.